Okay, this is 3.1's Formative Quiz. If you're using it as a study guide, make sure you go question by question. Just try the question, listen to the response, make sure you understand what you're doing. The first question says true or false, 3 squared is 6. The answer is false. Remember, all true false require an exclamation. The reason why either 3 squared is equal to 9 or 3 squared does not equal 3 plus 3. It equals 3 times 3. Something like that. You be the judge. So 1 point for the correct answer of false, and 1 point for a correct explanation as to what it should be. So the first question for 2 points.
Okay.
Question 2, the square root of 100 is 50. The answer is false. Square root of 100 is actually 10. Right? Or they might say the square root of 2500 is 50. But I think anyone said that. Right? But 1 point for the correct answer and 1 point for some semblance of the reason why it's false. Question 3, 8 is a perfect square because 4 plus 4 equals 8. The answer is false. In order for it to be a perfect square, it must be the product of two numbers, not the sum of two numbers. And you can gauge whether or not they had something like that, but in order for a perfect square to be a perfect square, there must be a number that multiplies by itself to give you a number. And since there is no number that multiplies by itself to give you 8, it is not a perfect square. Adding two numbers together that are the same is not how you get a perfect square. Question 4, 100 has 4 prime factors. So for this one, I will fully expect people to write down the prime factorization of 100. And I don't care what it looks like in terms of structure, but the endpoints are all going to be 2's and 5's. So the answer is true, and the prime factors are 2, 5, and 2 and 5. Question 5 goes on to your non-true falses. What is the area of a square whose side length is 20 meters? So I would expect people to draw it, right? And then the expectation is you will write your formula. Like I said last day, your formula for the area of a square is going to be area equals side squared. Then you will take that area and you will substitute 20 for your side length. And you'll have area equals 400 meters squared. Okay? So 1 point for the correct answer of 400 meters squared, and then 1 point for writing the formula and substituting correctly. If the person you're correcting didn't do that, you should probably make a note for them saying, don't forget to write your formula. Substitute and simplify.
It's okay to just write 400.
Question number 6, what's the side length of a square whose area is 64? So again, start with a square and put the area inside there, and put what is the side length. So formula is area equals side squared. 64 equals side squared. So when we substitute the area that we know, the S is not what we substitute this time, it's the A. And you learned yesterday that in order to solve it, you can square root both sides, because algebraically, whatever you do to one side, if you do it to the other side, it maintains equality. So you would square root both sides. The square root of 64 is 8. The square root of S squared is S. And therefore the side length is 8 meters. And 1 point for correct answer, side length is 8 meters. 1 point for the correct use of formula. Okay. Question number 7 says prime factorize 256 to prove that it's a perfect square. So prime factors here, we're going to use 2 to start because we know it's an even number. And it's 2 times 128 to give you 256. If you didn't know that, you could have taken your calculator and said 256 divided by 2 to figure out the other number is going to be 128. And 2 comes out because 128 is even at 64. There are multiple ways you could do this now at 64. You can go 2 and 32 if you wanted. I'm going to go to the old 8 and 8. And I'm going to break down each of these into 2 and 4 and 2 and 2. 2 and 4 and 2 and 2. So how many prime factors does it have? If I grab my highlighter here, 1, 2, 3, 4, 5, 6, 7, 8. It has 8 prime factors. And is it a perfect square? Yes, it is. Because you can take those 8 prime factors of 2's. With 4 of them on this side, put the other 4 on this side, and you will realize you can create the product of 2 identical numbers, which would be 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 16 is another way to get 256, and therefore it is a perfect square. Question 8. A square field has an area of 6,400 meters squared. So the first thing I would do, if this was my test, is I would draw the field, and I would put the area inside. How far would you walk if you went around the outside of it twice? So obviously, without saying it, we need to know what is the side length, because if I'm going to walk the perimeter of this field, I need to know how long the side length is. And I'm going to use my formula of area equals side squared to figure out how long the side length is. 6,400 is our area, and our side is unknown. We're going to take that formula, substitute what we know, and then square root both sides. The square root of 6,400 I need to use a calculator for. And I go 6,400, and in my calculator, where is it? I need to change it. Change the sign. So I'm going to go second function, square root, 64, second function, square root, tells me, 6,400. Tells me it's 80. So the square root of 6,400 is 80, the square root of s squared is s, and therefore the side length is 80. But am I done?
No.
No. So now I have to figure out, if I was to walk around the perimeter of this field twice, how many 80s would I want?
8.
8 of them. So then you would say 80 multiplied by 8 is the distance walked, which would be 640 meters. So, 1 point for work, 1 point for the correct answer. Right? This would be the work I would expect to see, and this is the answer that you would do when you reason it out. The 2 laps around that field would be 640 meters. Your next question says, is 200 a perfect square, and how many prime factors does it have? And use prime factorization to determine. So, again, same as the last question, we go 2 and 100. Here you can go 2 and 50, you can go 4 and 25. I'm going to go 10 and 10. 2 and 5. 2 and 5. How many prime factors does it have? It has 5 prime factors. And is it a perfect square? No, it's not a perfect square. Why? Because it's impossible to allocate those 5 prime factors to make 2 identical terms. Okay? So it's not a perfect square. 3 points for that question. Question 10, how many prime factors does 10 have? Well, that's pretty simple. 2. 2 and 5. Your next question gives you exponential form and asks for standard form, or gives you standard form and asks for exponential. 3 squared is 9, 5 squared is 25, 12 squared is 144, 100 squared is 100 times 100. So you probably need a calculator here, you think?
10,000.
Equal 100 times 100 equals 10,000, but watch, it's actually not that hard. When you square, like 10 or 100 or 1,000, just put a 1 down, and then double the number of zeros. Okay, here's 2 zeros, so here's 4 zeros, 10,000. 64 squared, I'll use my calculator, 64 is the standard form, so it is 8 squared. And 400, we know if it's on our wall, is 20 squared. 6 points for that question. And our last question gives us square roots. So the square root of 25 in standard form is 5. The square root of 1 is 1. The square root of 144 is 12. The square root of 1 million, if there's 6 zeros, your answer is going to have how many zeros? 3, half as many. So it's 1,000. And the standard form is 19, so what was it? It must have been the square root of, if you look at your wall, the last one we have is 361. That is worth 5 points.
Both tables or